All right, welcome to the CIDR subnet discussion. And does anybody out there kind of have an idea as to what we mean when we say CIDR subnetting, what we're doing? Does anybody have like heard it before, have a general idea? Anything along those lines? Is this completely new? So this is completely new? Clouds. All right, new for me. Okay, so what essentially CIDR subnetting is doing in a very, very general sense is taking a network and breaking it down into smaller and smaller chunks. That's essentially what we're doing. So if I have a IP number, what class is this?
C.
C. How do we know?
Because C
The
class starts
192.
with
Beginning
192.
octet.
Okay, so first octet starts with 192. That is the beginning of the C categories, right? Now, saying we didn't know that and we needed the subnet mask to tell us, what are the different ways we can identify or notate the subnet mask for this?
Whether it's a 255 or a 0.
Well, how would we notate it if it's a 255?
For the class C, like we know 255.255.255.37. So the 41.0.
37?
0.
There you go. So that's one way we'd notate it, right? What's another way we can notate it?
/24.
/24. What's another way we can notate it? The /24 is a hint.
Would it be /16?
Not for class C.
Oh.
So it'd still be /24, but it's just another way of saying the exact same thing. Where does the /24 come from?
Numbers of ones.
Binary
Okay.
form.
Binary form.
Binary.
How would we notate this in binary?
1111111 in 8.
Okay. Again, hint is the /24,
24 ones.
followed by
zeros.
how many?
8.
There you go. So 24 ones. So this is the way to binary represent subnet mask, right? It's a string of ones followed by a string of zeros. What do the ones and zeros represent in this picture?
The 1 represents subnet mask.
Subnet mask, and what does that tell us?
On and off.
On and off, yeah, that's what binary tells us. What is the subnet mask specifically telling us?
How many hosts?
Not quite telling us how many hosts, but we could figure that out based upon the subnet mask.
The net
The
and host
network
ID.
ID and the host ID.
There we go. So the ones in this picture are our network, the zeros are our host, right?
Mm-hmm.
And so we can see, like we said, we can see this as a /24. Now, there's what's called classful networking, which is the ABC that we've been talking about. And that's how all packets are routed over the internet. Now, when we get inside of our networks, we want to be able to use things a little more efficiently. And this is where CIDR comes in, and that is CIDR. It'll let me type it here. CIDR. And this stands for classless inter-domain routing. So we're kind of going to be, to a degree, removing the idea of classes with regards to our internet routing and making our network a little bit more useful for us is the main purpose. So now we understand the ones are networks, the zeros are hosts, right? Let's say I have 4 printers. Am I going to want to use and I don't want to really have that on the same network as my servers or, you know, my general operations or HR and that stuff. I want them on their own network. Do I want to waste 251 addresses just so I could put these printers on their own network? Probably not, right? So what we're going to do is we're going to start stealing bits in this last octet to make smaller networks. So if I take this last bit here and I put a 1 in the subnet mask, my subnet mask is all of a sudden a /25, right? Because I'm using an extra bit. Right? So let's ignore this portion. We're only focusing on this last bit. So I have 8 bits, and one of those bits is my network. I can have network 0 and network 1, right? Because I have a bit and it only has 2 options, on or off, right?
Mm-hmm.
So let's go over here and look at this. So if I leave this as a 0, and I start turning on bits, you can watch the green at the top. See how everything adds up. So I can start at 0, and then I can go all the way up to 127, and that still be a 0, correct? If I go to 128, that has to become a 1, doesn't it? So I have a range.
Correct.
So now I have a range for my network 0, this computer 0, all the way up to 127. Does that make sense? And now I have the rest of the computers. So let me go here. One, and I could start at 128, and then I start turning all the other bits on. And my upper range is 255. Does that make sense? So it's kind of like what we were doing with our class A, B's, and C's, right? So our networks 1 starts at, and theta going here, 128 to 255. So I have two networks. The network ranges are network 0 from 0 to 127. Network 1 goes from 128 to 255. So if I get this IP in, which of these two networks does it go in?
The second one.
Second,
So this last octet is 37.
It goes into the zero.
Oh,
0 to
oh, on the first
127.
one.
Oh, first
Okay.
one then.
Remember, we're focusing on the last octet, right? We know it's a class C, but what we've done is we've done a class C, and then we internally have said we want one more bit for our internal networks, right? So looking at the last octet, it goes in this one, right? Because 37 falls between 0 and 127. Does this make sense?
Yep.
Yeah.
Okay. Let's take it up a notch. /26. So we're going to take the second bit. So the first two bits are going to be our networks. So what different options do we have with 2 bits? So we have 2 bits. How many different varieties can we have with just 2 bits? I'll get us started here. 0, 0.
1 0.
1
0, 1.
1 1.
Yeah, 1, 1.
And 1 0.
1, 0, right? So we now have 4 different possible networks just using the 2 bits, right? Let's go back to our ANDing over here so we can kind of show it. So first 2 bits right here, 128 and 64, are going to be our network bits, right? So if we have 0, 0, we can go from 0 all the way
To 32.
to 63, right?
Mhm.
So we have
0.
notator.
Okay.
0 to 63. So what do we think our next one's going to start with?
64.
64. All right. So let me go ahead and turn this bit on. So we start at 64. And we can add our way all the way up to here, which gets us to 127, right?
Mhm.
So, boom, 127. Now, what else do we notice? So we have the 0 network, 0 and 0, 1 is basically just the 0 network, but it's cut in half, isn't it? So we've doubled the number of networks we have and the number of computers that we have in each network is cut in half, right?
Yep.
All right, so we can kind of go up from here. So 128, oops. Come back over here real quick. Just to kind of do our oops.
Yeah, great.
Go all the way up to 191. All right, so 128 and 191. Annotator here. So 128 to 191. You know, but what you can do is in your head is just cut this in half and then you know it. I'm just trying to show it to you visually in binary as well. And then you have 192, and where do we think where do we think this network ends?
255.
192.
255, right? 255. This is /26. So if I give you 192, oops, 68 dots, 183 dot 120. Which network does that fall in?
64.
What was that?
64 to 127.
Okay, which is network what?
01.
01.
01.
Notice when I'm drawing these out so that it makes it easier for me is I'm drawing them in order binarily. I'm writing them out in order. So yes, it would fall in this 64 to 127 network once it comes into our system. Does this make sense? Do we remember seeing in that lab that /26? This is what they were talking about. It's using this extra 2 bits for our networks, right?
It will always be the first 2 bits, or they can use the other. as
It's the
well?
first 2 bits if it's a /26. It's only the first bit if it's a /25, but then you have two networks, and these are your network ranges, right? Does that make sense, Majid?
Yep, yep. Thank you.
I
Okay.
have a question.
Yes.
For finding the ranges, you put ones into the 1, 2, 3, 4, 5, 6 category, or I don't know how to say it, but in the chart,
Up here?
no, on the left.
Oh, here?
Yeah.
What? Go ahead.
I just don't know what's the logic behind putting ones there, or how do I know to put ones there?
Well, when I'm doing that is if I put ones there, I'm maxing it out, right?
Yeah.
So I'm just showing you the upper, all I really need to know for my network ranges is the upper and lower ranges, right?
Mm-hmm.
So the lower range would be all of these being a 0.
Oh, okay.
Correct.
So, okay. Yeah.
The upper range would be all of them being a 1.
Yes.
So that's giving me the upper and lower range of each network.
Okay.
That was why I was doing that. All right. So we're good with /25 and /26, right? Say no if it's a no. Okay. You ready to try /27? All right, let's try /27 here. So let me erase these. We need room for /27. All right. So we're going to take that third bit. So 24 gets us to the dot, and then 25, 26, 27. So we're going to use the first 3 bits for our networks. So what are our options with 3 bits?
0, 0, 0, 0, 0,
0,
1,
0, 0,
001,
1,
0, 1,
then 011,
0, 1, 0,
and 011,
0, 1, 1,
and 111.
100.
110.
1, 0, 0,
Oh, yeah.
101.
1, 0, 1,
110.
1, 1, 0,
111.
1, 1, 1. Helps us get better at counting in binary though, doesn't it?
Yep.
So for /26, we had 4 networks, 64, spots in each network. Now we have 8 networks. How many spots do we think we're going to have in each network?
8.
Not 8. So each time we double the number of networks and we cut in half the number of spots. So for a /25, we had 2 networks and 128 spots. For a /26, we had 4 networks and 64 spots. Now we have 8 networks. How many spots do we have?
32.
32.
Right. Yeah.
So we have 32 spots, right? So first one is going to be 1 or 0, 0. So 31.
Okay.
The next one's going to be 32,
82.
63, 64, to 95, 96, to 127, 128, 159, 160, 191, 192, oops, 90. Go.
223.
223. 224 to what?
225.
255.
255. So there's our ranges there, right? So now my 192, 168.183.37, which network would that fall in?
001.
001, right here.
Yep.
All right, and my 192, 168, 183.120, where would that land?
011.
011.
011. Does it start to make a scary sort of sense?
It's coming together a little bit.
Yeah.
Need more practice.
Oh, you're gonna get practice. We're gonna do a few where y'all are gonna figure them out. So I can keep going with this. So like if I did a slash, and this was a /27.
27.
Yeah. So if I did a /28, how many networks would I have?
64.
16.
16.
16.
16.
So I have 16 networks. How many computers would I have in each network?
No.
Fif-
64?
50,
Let's face got it. 16 or no, almost there. 16. Because half of 32 is what?
16.
16. We had 32 computers or 32 spots in the last network. We cut it in half. We now have 16, right? So for every number we go up, we double the number of networks and we cut the number of spots in half. So remember, /25, which is one above the /24, which is our standard class C. Two networks, 128 computer or spots in each network. I go up one more spot, /26. I have 4 networks, 64 slots in each network. I go up one more, I have 8 networks, and I have 32 slots. Now I have 16 networks and 16 spots in each network. I go up one more, I'm gonna have 32 networks and 8 computers in any network, and then 64 networks and 4 computers in any network, or 4 spots in any network, and that's the highest you can go is a /30. But we don't need to go that high. /28 is probably about the highest we would need to go. Kind of get a good understanding of it. So this is giving you kind of a basic layout or understanding of what CIDR is. Now for Network Plus and all that stuff, they'll do a /23, which is actually coming back this way. And so you start having a lot more networks and a lot more computers when you start breaking it down that way. It's a little bit too much for where we're at right now. But it's just taking this concept and just building on it a little bit more. So does this make sense? A little bit? All right, let me grab the big eraser here and clear the drawings out. So, drop this in here. If I have a 192.175.186 /27. So that's what it's going to look like. So I want you guys, don't put it in chat yet. Don't put it in chat yet. I want you to figure out how many networks, how many spots, and which network this would go in. So I'm going to give you a minute to go on that. Let me pause the recording real quick. Oh. And this would look like a CIDR notation to the computer. So we showed you the /20 /25 or the 255.255.255.0 and then the /25. This is what the computer would see in our routing table. So it'd be 1, 2, 3, 4, 1, 5, 6, 7, 8, 2, 1. That's what it would look like.
/25.
Telling the router, and that's a /25
Right,
because we're using that extra bit, right?
Mm-hmm.
And a /26 would be boom, like that.
right.
And a /27, like that. So all we're doing is extending the network address a little bit, but allowing us to break it up in smaller and smaller chunks.
Yeah, I got that part. I just don't finding the spots or computers, like the amount is where I'm confused.
Okay, well, I mean, if you have
So
If you have a dollar and I say, give me 2 equal portions, how much do I have?
50 cents.
Okay. Now, if I say, give me 4 equal portions of a dollar.
25.
So we've doubled the amount of portions and cut the amount of money in half each time, right?
Right.
That's all we're doing. So we're taking each step of the way. And I still do this to this day, where I will start at /24. And I'll go, okay, 25 gives me 0 networks, 128 per network. /26 gives me 4 networks, 64 at each, because I'm cutting that 128 in half, right?
Oh, so I'm just going off of
Oh,
the 120
yeah, I
and going
get
down
it.
every time?
Huh?
I
What was
just
anyone?
didn't. Okay, so I start at 128 with the first bit in the last octet and then split it in half each time I go.
That's what I do. So I started like 24, which is 8. My last octet is all zeros, right? So
Yeah.
I have one network, 100 or 256 options, right? Or spots. And then I go, okay, so now I'm going to cut that in half. So I only get 128, but I get twice the amount of networks. Instead of 1, I now have 2. So no matter what I do, I have to get to 256. So 2 times 128 gives me 256, right?
Yeah.
Now I go to 4. 4 times what gives me 256?
64.
64. So now I have 64 spots and 4 networks, right?
Okay.
And then I have to double it again. So now I have 8. 8 times what gives me 256?
32.
32. So
That's
I'm
right.
doubling
32
one
and
side
16.
each time, and I'm cutting the other side in half each step I make.
Okay. Now I got it.
Does that make more sense?
Yeah, it does. I
Okay.
just didn't know how to start it off, but I can.
Yeah,
see.
but that's how I do it. I mean, I work my, because just straight memorization doesn't always work for me, but the math aspect of it does. So what I'll do is I'll start from a position I know, and be that /24, /25, /26, and I would build from there if I needed to.
Mhm.
So if I knew /26 would give me 4 networks, 64 in each network, right? So that's a /26, and I needed to know what /28 was. I could double it again and go, okay, 8 and 30, 8 and 32, and then 16 and 16. So that allows me to build it up. And then once I know how many I have, then I can start writing out my ranges. Right? So I'd go from 16, and 0 is a number, so I have to go 0 to 15. And then 16 to 31, 32 to and I just keep going up and up by counting by that number, how many spots I have, right? And if it's hard to do it from 0, just do it from 1 and then just -1 each time. So, first range would be 1 to 16, -1 because 0 is a number, you go to 15. Whatever's easier for you with regards to that. The key is just finding the trick that works for you to remember it easier. All right, want to try another one? Don't everybody say yes at once.
Yes.
Andre's
Yep.
tapped out. He's got this. 85.203 /26. Raise your hand when you're ready. How many networks? How many computers in each network?
203.
Yeah, 203. It's the last octet, 203. So how many networks? How many computers in each network? What network does this fall in? And what is the range of that network? The upper and lower limits.
Can you go over the steps after we are done figuring out on our own too?
Yes.
Okay.
Pause the recording. Just remember to raise your hand when you got it. All right, Fatih, explain us to, or let us know your thoughts, sir.
Okay, so for this, it's just going to be two networks, or I
Okay.
would say two ranges, 0 and 1. So for this class, it's going to be on class network 1.
Okay.
Range 128 to 255.
Excellent. That is perfect. So just to kind of do a walkthrough, kind of what he was saying. /25 means we were only using 1 bit for our network. So our options are 0 and 1. And the first network, we have the options of 0 to 127 or 128 to 255. And since our last octet was 129, it falls in network 1. Does this make sense? All right, we ready for a little harder one?
Wait, and how many spots was it?
How many what?
How many spots in each network was it? Was it 128?
128 spots in each network, yes.
Okay, yeah, cool.
All right, so. Y'all ready?
Yep.
Go. Nice job, 50 on the last one. I was about to say, Jamal, you're already on it. Oh, pause recording. Why don't you explain to us what you got, sir?
Did I get called out?
Yes.
Oh, it's because I'm having issues with my mic. But I got it on there's 16 networks and it falls on network 9. And there's 16 computers per network.
So it's network 1000.
Sorry, sir, I'm having issues. I don't know why I can't hear you guys, or I barely hear your voice.
What's the range of the network that you have it in?
I have it in 144 to 159.
144 to 159. All right, I believe that is network 101 or 1001, excuse me.
So that's what I'm having issues with. You know how you do 0, 0, 0, 0, 0, 0, 0, 1, and so forth. I'm having issues with the order of that. I guess
Well,
the 1, 0, 0, 0.
mhm,
I guess can you do it for 28?
sure.
Okay.
So where the ranges are kind of like how you do that counting. Let's see here. Just to kind of show you from this perspective here. So let's just look at the last 4 digits, okay?
Okay.
So to count up, we're gonna have 16 possibilities, right? So first possibility is 0001, which gives us 1, right?
Right.
So to go to 2, we would have to turn that back to 0 and then move the second bit up to 2, right? So now 2 is 0010. Make sense?
Okay, gotcha.
And then 3 is going to be 0011, right?
Right. Yep.
And then to turn on this next bit, it would be 100. Oops. So it would be 100. I think this is 4, correct?
You're right.
And then we got 5. It'd be 0101 gives me 5. For 6, I have to turn that first bit off, second bit on. So then I have 0110. So do you see how where those numbers are starting to come from?
Makes sense. Yeah. I guess it probably would have been easier if I did it in the chart because I got the answer, but only because how I broke it down like mathematically.
Yeah.
But
And I do
didn't
that.
know
I
what-
do that as well with the binary, and I count up in order in binary to make it so that I keep track of the networks easier. That's a personal preference of mine.
Right. Okay.
But if you can find the range that it falls in, you're going to do just fine. I just have
Okay,
an
cool.
extra step on mine.
Okay.
All right. Did this one make sense to a lot of people, or do we need to, work it out?
Wait.
And can you work it out?
Yep. Give me a second. Okay. So we have network 0000, 0001, 0010, 0011, 0100, 0101, 0110, 0111, 0111, 1000, 1001, 1010, 1011,
100.
100, 1101, 1110, and 1111. All right. And then we got to do our ranges, just so we can kind of be clear on all of it. So we have 0 to 15, 16 to 31, 32 to 47, 48, 63, 64, 79, 80, 95, 96, 101, 2, 27, 28, 43, 144, 145, 146, 159. Oops, 144 to 159, sorry. 160, 175, 176, 191, 192, 207, 208, 223, 224, 239, 240, 255. So we see where our ranges came from?
Yeah, it just clicked. It just clicked to me.
And then 145
Would be
falls into this network here, 1001. All right, 'cause it's in between 144 and 159. Makes sense?
How did you get the range?
yeah.
Who asked the question?
How did you get the range?
How do I get the ranges? So I knew I was gonna have 16 networks and 16 computers in each network because starting from /24, I have one network at 255. /25, I'm gonna double my networks and cut my slots in half. So I'm gonna have two networks, 128 computers. /27, I'm gonna have, or excuse me, /26, I'm gonna double my network, so I'm gonna have 4, and I'm gonna cut my computers in half, so I'm gonna have 64. /27, I'm gonna have 8 networks. I'm doubling my networks, and I'm gonna cut the number of computers in half, and now I'm gonna have 32 in each. /28, I'm gonna have 16 networks and 16 computers, so it's equal. And so how I got my ranges is I started at 0, added 16, so I got to 15. I started at 16, added 16, got to 31. Because remember, we got to count the 16 as 1. And then I just kept adding it up, going up 16 each time. Does that make sense, Tamana?
So 0011. Are all those 16 you added 16 to all of those?
I'm sorry, I can't hear the question.
Did you add 16 to all of those? Like each section you added 16 to different things?
Yes. I just went up 16 spots on every single one. And that's how I ended up with these ranges. Any questions on this? Is this making a little more sense?
So question, when you're breaking down the zeros, those zeros are not, for example, I know 0001, it's 1. Are you adding them together to get the order and range of the networks? Is that right?
All I'm doing is I know I have 4 bits, so I'm just kind of counting from the first network all the way up to the last.
Okay, so it's not really like, if I plug those numbers in there, it's not going to add, like, for example, last one's not going to add, of course, it's not going to add 16.
No.
Yeah, that's the only part I'm totally losing it right there.
Okay. I do have a video real quick. I'm going to show y'all. Pause it real quick. I have two videos actually. And see if